So we'll talk about the what we call here is double hashing. Double hashing is also a technique of open addressing, which states that the numbers in case of collisions should only be stored in the hash table itself and not in the separate chains. And apart from linear probing and quadratic probing, we have this third one technique here. And we have two hash functions in this technique. That's why it's called the double hashing. And we have some entries to work into. The function or the formula here is h1k. You get the first index and then you get the second function. Sorry, and then you mod it with your size. I is basically the prob means the attempt to find an empty slot. So I is going to be the first attempt. If we are failed to find any empty slot, we will do a second attempt. That's what we did in the quadratic probing when we had this one as 1, 2, and 3, and 4. Mostly it goes for like 4. And in the previous one, I really forgot about the smart M thing here. I didn't write that down, but it doesn't affect the whole answer, so I mentioned it in the comments. But modem is also necessary for the quadratic probing, so just a bit correction for the previous one. And for this one, we're going to start working. So first of all, we have 49, and we have our first hash function, the first one, which is always given, which is 49 mod 7, because 49 is always divided by 7, so that's 0, so we'll put the 49 here. Then we have 63, again 63, 7 nines are 63, so it will again go for 0. In this case, we have a collision, so we will use this function. What was the first function we had? We had k mod 7 plus, this is my first attempt to find an empty slot, and my second function is 1 plus k mod 5, okay? 1 plus k mod 5, and then for all this thing, we have a statement which is mod m, right? I don't have my space here, but now what is k here? It's basically 63, right? So 63 mod of 7 plus 1.1 plus 63 mod of 5, and I'm not going to write that one here, I will do it. So this gives us 0 plus 1 dot, because 63 is completely divided by 7, 1 plus 63 divided by 5. So 5 5s are 36, 5 9s are 45, 5 10s are 50, 5 11s are 55, 5 12s are 60, right? And what is 5 13s are? So that's 3 5s are 15, and 65 is the bigger number, so we'll use 12 5s are 50, right? And now we will write here, because this 60, we will have 3 as the remainder, so we will use 3 here. Right, so I'm gonna write 3 here. Now it becomes 0 plus this is 4. 4 ones are 4, so that's 4. And because we have already had this mod here, so we'll use this one here's mod of 7, which was 7, the size, we written at the start. And then 4 mod 7 is going to be 4. And 7 zeros are 0, so that's 4, so that says 4. So it means 63 go to the index 4. Sorry, that's 63, I've written 4 here. So we'll write 63 here, right? And this was our first basically idea of the collision and how we really performed, because in double hashing we basically have two functions, and using those functions we basically do all the work we have, okay? If we have any problem in case of collision. In separate chaining it was quite straightforward, but it could be a little tricky when you were really implementing it, because we have to kind of made nodes, and then we have to connect those nodes. Then we have 56, so 56 divided by 7, 7 8s are 56, right? So that's also completely divisible by 7. So again, it is giving us some error, and now we are going to fix that error. So I'm going to take this one here. So it's again collision here. So we'll write the function again. We have k, which is 56 mod of 7 plus this is our first iteration, means first attempt, the prob, and then we have 1 plus 56 mod of 5. And this is what I'm already putting these functions here. Try them on yourself as well. So this is 0 plus 1 dot 1 plus 56 to 5. 5 8s are 40, 5 9s are 45, 5 10s are 50, so 5 11s are 55. So that will give us 1, right? So 0 plus basically this gives us 2, 2 equals 1, 2, that's 2. Then this mod here, so mod of 7, this will give us 2 because we will have only 2 here. So the second index would have 56. Easy peasy, right? So we can find this way. We are also going to give it the functions we asked for, okay? Now for the next question, we are going to again look for these things and kind of guess through them. We have 52 now, so 52, I think we'll go for 50, like, because 55 is bigger, so we are going to do it with 7, so 7, 5's 35, 7, 6 42, 7 7s are 49, 7 9s are 63, 7 8s are 56, so 7 7s are 49. So this comes 4, this becomes 12, minus 9, it's going to be 3. So now 3 is kind of cool here, so 52, we're going to just put the 52 here. Okay, and now we are going to have 48, and now I'm going to have the 48 and 7, so 7 7 are 49, but 7 6 are 42, so 8 minus 2 is 6, and the index is 6, so we're just going to put 48 here. Notice that the whole entries are lesser than the size of the hash table. This can happen, okay? But we need to find the correct indices. So this was double hashing and the formula.